Welcome to the third lesson on momentum. Up until now, we've talked only about the mass in motion or momentum. But since we have moving objects colliding in many systems, it's important to find out what is happening to the energy in the system, specifically the kinetic energy. Now, it's important to make a distinction between conservation laws and principles. We know that the total amount of energy in an isolated system must be conserved. The total linear momentum must also be conserved, but the same is not necessarily true for the kinetic energy. Almost always, kinetic energy is changed into heat, sound, or other forms during a collision. If no energy is lost, the collision is said to be elastic, and all the kinetic energy of the system is maintained. If kinetic energy is changed in any way, the collision is said to be inelastic. Now, since the equations for the conservation of momentum looks so similar to the next part, we need to be very careful when we try solving problems involving elastic collisions. First, we add up the kinetic energy of all objects before the collision. Then, we repeat it for after the collision. Do not make them equal. We are trying to compare them to see if they actually are. If they are equal, then the kinetic energy has been kept the same, so we can conclude that the collision was elastic. It's far more likely that the two numbers do not equal one another, so that means that the collision was inelastic. Be very careful. The wording and the equations can be tricky. Let's go back to one of the examples of two cars, X and Y, from a previous lesson. In that lesson, car X collided with car Y. Car X with an initial velocity of 10 meters per second and car Y with a velocity of -5 meters per second. So, substituting their masses of 1000 and 1100 into the equation for kinetic energy is the next step. Adding it all up shows us that the total kinetic energy of the two cars before colliding is 50,000 for car X, 13,750 for car Y, a total of 63,750 joules of kinetic energy. When they collide, they remain stuck to one another at a final velocity of positive 1,62 meters per second. Finding the final kinetic energy of the combined objects, we use both masses multiplied by 1,62 meters per second squared. So, the amount of energy should be the same or less in most cases. If we compare the two, the amount of energy after the collision is only 2,755,62 joules. That means that a large amount of kinetic energy was transferred into other forms. The collision is definitely not elastic. The correct term to use is inelastic. Some of that energy is used to deform the shape of the car, and in fact, parts of the car are designed to fold neatly and change shape. These are called crumple zones, and they absorb a great deal of the energy when they fold up the shape of the engine compartment. If the collisions between cars were more elastic, the changes in velocity would be greater and the occupants would have a much higher risk of injury. The only collisions that are close to being elastic are collisions between atoms at low temperatures. So, if you find that the energy does match, be very careful that you've substituted numbers correctly. Be very careful when you do these calculations that you do not assume that the kinetic energy before and after the collision are the same. You must find them separately and then see if they are the same. Remember that momentum questions are among the easiest to prepare for, as they are all roughly similar in approach, and provided you watched your vector signs, you should excel in them.